Okay, so you guys are trying to identify four separate linear equations, both of which have an x and y. So there's some form of graphing that could take place here. And you're trying to identify which lines out of these set of four are parallel or perpendicular. So we talked about y equals mx plus b, and that being very important because when y is by itself, you can easily identify the slope as the y. So a lot of times what I want to do is get the y by itself. First thing you want to do is usually move your x. You want to move your x, and then you get 6y is equal to negative 2x plus 9. And then you want to get y by itself by dividing 6. End up with y is equal to negative 2x over 6 plus 9 over 6. And important thing here to do is to reduce your equation to y equals negative 1/3 x plus 3 over 2. And here's my equation, which in turn gives me a slope of negative 1/3. That's what I'm working with there. Now as I go through these other lines, I'm also trying to identify and by getting y by itself. Now I presented this one because it has this idea of, okay, you have a negative y. So technically what you're doing is dividing by negative 1. Personally for me, I feel like this is just something that helps you understand, but it is maybe a little bit waste of time because I look at this, I'm just gonna change signs. Right? I just want to change the signs here. That's all I'm really concerned with. Now I'm looking at this slope here, right? I have a slope of 3, okay, and this slope here, and right away, okay, I've identified a slope which is flipped, because technically this is 3 over 1, flipped, and opposite signs. So right away I know 1 and 2 can give me a perpendicular slope. I'm going to look here at the negative 12x, again, just trying to get y by itself. Negative 4y is equal to negative 12x plus 20. Divide by negative 4, divide by negative 4. Y is equal, I'm just going to reduce here. 12 divided by 4 is 3. A negative is a positive, so positive 3x minus 5. Now, another thing I did here, I did throw this in. Okay, I have a slope of 3 here, which is the same slope as this, which would mean they're parallel. But what I did as a curveball, yes, if we were just looking at slope, these would be parallel. But you also have to consider here and pay attention to the fact that your y-intercept on both these lines are the exact same. And what that tells you is these lines are not parallel, they're actually the same line. And I did that just to present a different curveball there. Now, let's just say this was, instead of minus 5, let's just say it was a plus 8, let's say, and your y-intercepts were different, then yes, you could say these two lines here would be parallel. All right? I threw that in there. If you end up with the same slope and the same y-intercept, that's the same line. If your slopes are the same, but your y-intercepts are different, then you can say that's parallel. Now let's just look at this last one here. Adding the 5x, negative 15y is equal to the 5x plus the 30. Divide by negative 15. Negative 15. I end up with y is equal to negative 1/3. I'm reducing that. 5 goes into 5 once. 5 goes into 15 3 times. Minus 2. Now here you have an instance where because this slope is 1/3. That is parallel to number 1. So 1 and 4 are parallel. And the reason that's okay is because, again, look, the slopes are the same and the y-intercepts are different. So since the y-intercepts are different here, I could say these two are parallel. And actually, you could have said 2 and 4 are perpendicular, 2 and 3 are perpendicular. So actually 1 is parallel to 4, same slope. 1 is perpendicular to 2 and 3. And the same thing goes for here. 4 is also perpendicular to 2 and 3 here. And we know that just by kind of looking at our slopes, we could say 1 is parallel to 4 and perpendicular to 2 and 3. Right? And if I gave you this, maybe I'd give you some blanks to fill in and saying 1, this, that, 1 is parallel, and that's something you would have to look at.